solving one variable inequalities. So you've been solving equalities, equations with equal signs, for quite some time now. Before we actually do some solving, we want to double check that the rules we've been using for solving equations, equalities, equal sign equations, still continue to work for inequalities. So we're going to start with an inequality. 5 is greater than -2. And we're going to test some of our steps. So we know that with equalities we can add to both sides. So we're going to try that here. And we want to see if our statement stays true. And it does. 5 is greater than -2. 9 is greater than 2. So still true. The next one we want to test is whether or not adding a negative to both sides. We also look at this as subtraction. So I subtract 4 on both sides. I get 1 is greater than -6, and that is also still true. Next, I want to test multiplication or division of positive numbers. So I'm going to multiply both sides by +2. I could divide, it doesn't matter. And I get 10 is greater than -4, and that is still true. Lastly, I want to test to see if multiplying or dividing by a negative number still holds. And so I'm going to divide both sides by -1. And then I get -5 is greater than +2, which is not true. Which means in order to keep it true, I'm going to have to flip my inequality. So when we are multiplying or dividing inequalities by a negative number, we need to flip the inequality. So now let's look at a couple examples. Example 1. Solve 3x minus 8 greater than 10. So we know that all of the rules of adding, subtracting, multiplying, and dividing both sides of equations hold for inequalities except for one special case, and that's when we're dividing or multiplying by a negative number. So we're going to solve this just as we have always solved our equations. Add 8 to both sides, divide by 3, and we get x is greater than 6. And I didn't have to change my inequality here because I didn't divide or multiply by a negative number. Example 2. Solve -1/2 x plus 7 is less than or equal to 4. So I start off using the same process. I subtract 7 on both sides. I get -1/2 x is less than or equal to -3. And now I need to get rid of this -1/2 x. -1/2. It's multiplying with x, so I could divide both sides by -1/2. Alternatively, I could multiply both sides by the reciprocal, -2/1. When I do that, these cancel and I'm left with x. And then I have to remember that this is the special case when I am multiplying both sides or dividing both sides by a negative number, -2/1. So that means I flip my inequality and then I do my multiplication. My last example is not a solve, but it's a question that you'll often see, which something like, is 4 a part of the solution set of 3x minus 1 less than 4? So in order to test this, I'm actually going to plug in 4 for x. That's what it's asking. It's asking, does 4 plugged in for x make this statement true? So I have 3 times 4 minus 1 is less than 4. And then order of operations, 12 minus 1 less than 4, 11 less than 4, and this is false, which means we're going to say, so 4 is not a solution to 3x minus 1 less than 4.